the tech study channel so in the previous class I have explained uh, fifth half answer fifth question's half answer, uh, that was types of entities, okay, with example. And in this class I will explain types of attributes. So in this class we will see what is entity type, what is entity set with example, and what is attribute and types of attributes with examples, with example, and representation of attributes in ER means entity relational and relational data models. Okay, so to understand these types of attributes we have to understand entity type and entity set. So entity type means entity set. First, entity set, a collection of similar entities or brackets objects, people or concepts that shares the same attributes. Okay, means similar entities means consider one entity, that is employee. Okay, here the similar entity means employee 1, employee 2, employee 3 plus so on. Okay, like this. So those are called similar entities. So entity set is a collection of similar entities, objects, people or concepts that shares the same attributes, that have same attributes like employee name, employee salary, and employee ID, etc. like that. For all employees, employee E1, employee 2, employee E3 plus 1, they have same attributes, means columns. And in relational database, an entity set is simply the entire table. Okay, in relational database, an entity is a simply entire database where each row is a single entity. Okay, like employee 1, and each column is an attribute. Entity set is a table, entire table where each row is a single entity and each column is an attribute, which is same attributes for all these individual entities, which satisfies the entity relation and entity set definition. And then example is student entity set for a university. The entity set, the entire table of all students is entity set, and attributes or columns student ID, name, age, course, here are there. And entities or rows, each individual entities like 101, 102 and 103 student IDs. Okay, so one row example is 101 John 20 CS, means computer science, means entity set means entire table. Okay, remember this. Okay, means it is a collection of similar entities like this, different employees. Similar entities means here in this case different employees have the same shared attributes like name, age and course. That's why it is a entity set. Then entity, one specific real world object. Okay, Example, the student Sarah. And entity type, the blueprint or category. Example, student. Means student, what it represents, table name. And then entity set, the complete group of all those entities stored in the database table. Okay. Then what is entity type? Entity type means a category or template for objects that share the same characteristics or attributes or columns. Okay. Category for the objects. Okay, that shares the same characteristics. Example, student. If it is a header of a table that defines what kind of information will be stored. Like header is here student, and then name, the label for the category. Example, employee. And attributes, the properties that describes every entity in that category. Like example, name, id, age. Then entity type. Example is a student entity type. Entity type is a student. Okay, this is the category name. Okay, means about which topic the table is uh, established. That's the category. Okay, that is student. Okay, and attributes, student id, name, date of birth, course. Individual entities, entity 1 101 abc, and date of birth is there, and then course. And entity 2 102, name Bob, and date of birth and maths. So here in the definition of entity type and entity set, there is a difference. Entity type is a category for the object, okay, that shares the same characteristics. Means attributes, means this entity type includes the table name as well as the columns of the tables. Okay, and in the entity set definition, it is a collection of similar entities that shares the same attributes. In similar entities means rows, which are in the rows, like employee 1, E2, E3, plus so on, that shares the same attributes, plus columns. Means entity set includes rows and columns. That's why it represents entire table. Okay, in this example. And then both entity type and entity set are represented by rectangle in ER diagram. As we all know, entities are represented by rectangle in ER diagram, and these entity types and entity sets also represents the same by rectangle only. Okay, because they are treated as the same visual component. We draw one rectangle writing the name student inside it, and that single rectangle represents the both blueprint, means category or type, and collection or set of that entity. Okay, and this is in the AR model. And in the relational database, means in the not in the relational, in the real database implementation stage implementation stage, the table represents the entity type and holds the entity set. Okay, the table represents the entity type and holds the entity set, means a whole collection of rows and columns. And a data type, table name and columns. Okay, so table structure like columns. Okay, how many columns are there and what are they? So represents the entity type, the definition or blueprint. Okay, and the table content rows represents the entity set, means the actual collection of data. And then we will see the definition and representation of types of attributes. Definition of types of attributes in the ER model and in relational model. Both in both the definition will be same for types of attributes, and representation will be changed. Okay, so what is entity? Entity is an property of an attribute, na. Uh, so in ER entity relational model and in relational model, types of attributes definition will be same and representation will be different. Okay, so attribute means the property of an entity, the properties of an entity, means entity is a real world thing uh, about which we want to give information, like if a student is an entity, then their attributes will be student name, age, gender, class, like that. Okay, and then we have six types of attributes. First is simple attribute, composite attribute, single valued attribute, multi-valued attribute, and derived attribute and key attribute. Okay, so first is simple attribute are those attributes that can't be divided further. Those attributes which that can't be divided further. Okay, that means if we consider address, then it can be divided into pin number and house number and street number, like that. But age, it can't be divided. It should be a single one number. Okay, and class also, and college roll number, which can't be divided further. Here student is an entity and these are all attributes: age, class, and college and roll number. All attributes are simple attribute because they can't be divided further. For a student we can't divide age. Okay, and we can't divide class and we can't divide college, like that, and roll number also. So, and then composite, then the representation in relational model means, we already know relational model means data will be stored in table format. Okay, and in ER model we represent the data as a diagram, means in terms of entities and relationships, attributes. Okay, using attribute symbol, entity symbol, and relationship symbols, we represent the data in the ER model. So this is the simple view in the ER model, and this is the simple view in the relational model. So here simple attributes. Example is employee table. Simple attributes represented by single standard columns in the table like age and department. Employee ID, age, department. These are the examples of simple attribute. We represent relation in relational data model like this. Separate tables for all simple attributes. Okay, and then composite attribute. Those attributes which are composed of many other simple attributes. So here student is an entity. Roll number, address and name are attributes. So these address and name attributes are further divided into simple attributes, which are S name for F name and M name, means middle name for first name and full name and starting name, and address is house number, street and pin. Here address and name attributes are composite attribute because they are composed of other simple attributes. Means these S name and F name and M name attributes can't be divided further. Well, okay, these composite attributes are these name and address, which can be divided further, but these can't be divided further. Okay, then in the composite attribute in the relational database, example employee table, composite attributes are flattened, means divided, by creating separate columns for each subpart in the main table itself. So in the main table itself, these are the composite attributes. Full name, first name, middle name and last name. John Robert Smith, Sarah Jean Doe. So along with other attributes also present in this main table. Okay, we are not writing this composite attributes in a separate table. We are including it in a main table itself. Okay, and then single valued attribute. So those attributes which can have only value for a entity from a entity set. So entity set, we already know the collection of the similar entities with the same shared attributes. So those attributes which can have only value for entity. So here entity is student. These are the attributes: date of birth, roll number, age, class. So a student can contain only one roll number, and a student can contain only one date of birth, and age also only single value, and class also single value. Here all attributes are single valued attributes they have they only because they have only one value for an entity from an entity set. Entity set means entire table. So these attributes, age column, age, date of birth, roll number, means these columns age, date of birth and roll number have only one value for a specific entity in the entire table. Okay, Means in each cell consider one cell. Okay, attribute is name, and one entity is 1001, which is student id. Okay, it has only one value, that is abc. It does not contain array of values. That's the meaning of single valued attribute. And then multi representation. Single valued attributes, example employee ID. Single valued attributes are represented as one column where each row has a single data point. Example is single data point means a single individual piece of data or information. Here we can observe national ID and employee ID are single valued attributes, means which have only one value for each cell for that particular column. Then multi-valued attribute. Representation in the ER model will be like this, and definition is those attributes which can take more than one value for a entity from an entity set. So here entity is a student. Here mobile number, hobbies, email, roll numbers are entities, and email, hobbies and mobile numbers are multi-valued attributes. Roll number is a normal attribute. Okay, so a student can contain multiple mobile numbers, and a student can have multiple more than one hobbies, and a student can have more than one email IDs. So that is the meaning of this multi-valued attributes. Attributes which can take more than one value for a entity. Okay, a student entity have more than one email IDs. So value is here, value represents email IDs, one or more email IDs, one or more hobbies, and one or more mobile numbers. Okay, from an entity set. Okay, means these attributes are having multiple values. Okay, multiple values for this particular entity, which is student. And here email, hobbies, mobile number are multi-valued attribute because they take more than one value for a entity from an entity set. Okay, and then in the relational model, how it represents means so because relational database can't hold an array of values in a single cell, means consider this table. Okay, this particular cell can't contain list of values. Okay, means array of values abc comma abc comma cdf comma, we can't contain more than one name. Okay, that is we are saying here, because relational database can't hold an array of values in a single cell. This is handled in one of two ways, that is creating a separate table to store the multiple values. Here we are creating separate table other than main table. So in case of composite attributes, we have included composite attributes in the main table itself, but in the multi-valued attributes we are creating a separate table for storing the multiple values. Means like email id 1, email id 2, email id 3 plus so on. Okay, for that but uh, particular email column. So how we are storing by separating tables means here in the example employee table is there, employee ID there, and employee name is there, 101 102 John Smith Sarah Doy. Here we are making associative table means separate table for the multi-valued phone numbers. So to overcome the redundancy, okay. If uh, if I if I put this phone number column in this main table itself, then it causes severe redundancy, because the employee name should be repeated as well as the employee ID also should be repeated. If here primary key is there, employee ID is a primary key, then we can create another table so that redundancy will be reduced. Okay, we don't need to duplicate the employee names. Okay, mm, for multiple phone numbers for a particular employee name, there will be a multiple phone numbers is there. So in this diagram we are presenting the multiple phone numbers example for a student in the relational data model. So we have created a associative table means relationship, it holds the relationship as well as the uh, its own attributes. Relationship means the association between two entities, and associative table means it holds the relationship plus it holds its own attributes, that is phone type. Okay, so here we are presenting different mobile numbers using a separate table which is associative table. This employee ID 101 has two numbers which works for mobile and which works for uh, working purpose. Okay, and then second method is creating repeated columns email 1 email 2 in the main table. Not recommended as it limits scalability. Scalability means the ability of a system to growing amount of data or work without breaking or slow down or needing a complete redesign. So this second method is not recommended because of it limits the scalability. Because the amount of data can be increased and the ability to um, maintain that growing data can be breakable. Okay, so that's why scalability is not supported here or satisfied for that particular method. So that's why it is not recommended. And here in the second method we are using creating repeated columns. Okay, creating repeated columns like email 1 email 2 in the main table. So we have taken mobile number example now. So here we can, in the main table itself, we can include employee in mobile number 1, employee mobile number 2, like this. So here, if employee ID is 101 and the name is John, and one mobile number will be here 9865, like that, anything, and here another mobile number is there 62 plus so on is there, and for another employee, similar data will be similar, process will be repeated. Okay, like Sarah, so on, 2 4 plus so on, like that. So it shows two methods, okay, to represent in the relational data model. So one is separating table and one is separating columns. And then derived attributes. Derived attributes in the entity relational model represents like this. So our derived attributes are those attributes which can be derived from other attributes, means which comes from other attributes. Here age is derived attribute because it is defined, it is derived from date of birth. Here derived attribute is represented by dotted circle, dotted oval. So here age is derived from date of birth attribute. Okay, using some functions we can derive it. Okay, and in the relational data model, derived attributes are, it is omitted from the physical data table. Data physical table design means we are not including derived attributes, means derived columns in the table, because to prevent data duplication. uh, why? Because a table can store, okay, a, a table, if we have a table like this, and here we have employee name, okay, and age is there. So employee name can be repeated twice. So age age also should be repeated twice, okay, for that particular employee name. So that's why it creates a duplication. So to prevent that, we are not including age column. Okay, means we are not including derived attributes. If here department ID is department ID is there, okay, D10 and D20. If this particular employee is working in two departments, D10 and D20, and this derived column should be repeated twice. So that's why we are not including derived attributes in the table. Okay, and update errors, to prevent data duplication and update errors. So update error means if underlying data changes, but if we forget to update the derived column, then update errors will come. There will be a confusion between data. So here underlying data means employee name or employee ID changes. So here in the underlying changes means if DID and E name, employee name is changes, and we forget to change the age column, then there will be a update error. Okay, so we will be in the confusion that and we can't get a proper information about a particular employee name. Okay, if we derive a particular ABC age earlier, and if we if we uh, query a person's age, okay, earlier ABC and some age is 30, and after updating this only employee name and employee name, we are again querying this table. This time we got DEF employee name and age will be same 30. So there will be an inconsistency in the data. So that's why update errors will come. Okay. To prevent that, we are not including this age column. Okay. And instead it is generated at a query time using view or computed dynamically. View means uh, selecting a part of a table. Okay. Like I want only these two tables from this entire table. So using views, I will access these two columns from this particular table. That's the meaning of view. So it is generated at query time, means derived attributes are generated at query time using views or computed dynamically. So here the view example is there. From a particular table which has columns employee ID, employee name, date of birth, age, and employee salary, we have taken only selective columns, that is employee ID, date of birth, and age. Age we have derived here, that is select age is equals to date if bracket of year comma date of birth comma get date. Here year is 1995, date of birth is 4th month, and get date 12. It will generate an age. Okay, so that's it for today's class. All attributes are completed, and key attribute is also there. So key attributes are those attributes which can identify entity uniquely from an entity set. So entity is a student here. Roll number is a key attribute. Why? Because it is unique and not null value. This particular roll number column will not contain any duplicate values and any null values. That's why it is made as key attribute, which is also called primary key, which identifies each row, means each row of these particular columns uniquely. So through that we can delete or update, or we can do insert in the tables. If we consider an example, how it is useful means, if 101 and 102 is a primary key, student ID, okay, and name ABC, and here also ABC name is there. So don't consider this name, okay, ABC and ABC name it is, and email ID abc@gmail.com and efg@gmail.com. Two emails are there for a particular person, but identities are different. Okay, if we want to delete some particular row from these two rows, we can use this 101 id to delete that. Means it is a primary key, like where student id is equals to 1001 delete row. We can use query like that. So we can delete it, and can be helpful. Means it is uniquely identifying these rows. And then here roll number is a key attribute because it can identify every student uniquely. In the primary key definition, we have seen that it does not contain duplicate values and null values. So that's why roll number is also does not contain any duplicate value and null value. It is unique for every student. So in the relational data model, how it will be means, one table is there like employee table, employee ID is there, employee name is there. Okay, employee name can be same. Okay, but id can be id will be different. Okay, and salary is there. So this particular column is used to identify this particular employee with the different salaries. Okay, this is the primary key or key attribute. Okay, in the relational data model we represent like this. So that's all for today's class. If you feel this video is helpful, then like, share, subscribe and comment it. If you have any doubt, ask me in the comment section. Hope you understand this video. I will see you in the next class. Thank you. Bye. So before ending this video, uh, I want to explain tangible entity and intangible entity. So because I forget to explain tangible entity and intangible entity in the uh, first part of this fourth video, so that's why I'm explaining now. That is tan entity, we already know, a thing, a real world thing which about which we want to give information. So tangible entity means physical objects, like example car, laptop, employee. And intangible entities means logical concepts like bank account, project, flight booking, like that. Okay, so here tangible table is there. Name is laptop serial number, brand and model is there. Some numbers are there, and Dell, Apple and uh, latitude and MacBook. Okay, so and intangible table is there, that is warranty. So only consider this table, this only this table consider only consider two columns. Okay, warranty ID and type. Okay, W500 and W501, 1 year basic and 3 year premium. So here if we want to connect laptop table and vanity table, means tangible entity and intangible entity, then we have to use primary key and origin key. So in this, what we have, primary key is laptop serial number is a primary key column in the laptop table, and in this we have to, if we want to connect it, then we have to use a primary key of this table as a origin key in this table. Okay, so that we can connect both tables. Okay, warranty needs a origin key from laptop primary tables primary key to connect tangible and intangible tables. That's why a origin key and primary key is needed. Okay, so okay, that's all for this particular tangible and intangible entity. Okay, if you feel this video is helpful, and like, share, and if you feel this video is helpful, then like, share, subscribe and comment it. And if you have any doubts, ask me in the comment section. uh, I will see you in the next class. Thank you. Bye.